Hi guys, myself Nishad. I am here to discuss about the properties of logarithm or logarithmic functions. Then we will derive all the properties, followed by we will do some good problems so as to make your construct strong. So we know that for any positive real number, logarithm is defined. Log of n to the base a is equal to x, and the condition is a greater than 0, a not equal to 1, and n is greater than 0. This is the definition of logarithm of any real positive number. Okay, then we have the second and third properties. For the second property, we can write log n to the base n is equal to 1. We can write this in exponential form as n raised to x, that is equal to n. Okay, so this is equal to n raised to 1. So comparing the powers, x is equal to 1. This is a proof of second. And the proof of third property is log n to the base 1 by n is equal to question. We can write this in exponential form as 1 by n raised to x, that is equal to n, or n raised to minus 1 whole raised to x is equal to n raised to 1. This is equal to n raised to minus x is equal to n raised to 1. So comparing the powers, this implies minus x is equal to 1 or x is equal to minus 1. So this is the proof of second and third properties. Now log minus 4 to the base 2 is equal to, since here the number is minus 4 and logarithm is defined for n greater than 0, this is not defined, or log 1 to the base 2, this is equal to 0. For logarithm of 1 to any base is equal to 0. In general, log of 1 to any base a is always is equal to 0. Right. Now, log 2 to the base 1. What is the value? Since base should not be equal to 1, this is not defined. Now, log 1 to the base 1, here base is 1, a should not equal to 1, so this is also not defined. Now, look at log 0 to the base 10 is equal to question. And as per the definition, n should always greater than 0. So this is not defined. But we have to remember the value of this is equal to minus infinity. Okay, or in general, log 0 to the base a is equal to minus infinity if a greater than 1. Okay, and log 0 to the base a is equal to plus infinity if 0 less than a less than 1. This is an important properties, since this is not defined, but the value of log 0 to the base a is equal to minus infinity if a is greater than 1, or it is equal to plus infinity if a is lying between 0 and 1. So we have to remember these properties. Let us prove this property. Okay, we can prove that property either graphically or mathematically. First I am going to prove it mathematically. Okay, now log of 0 to the base 10. Here 10 is greater than 1. So base is greater than 1 is equal to question. Right. Now we can write this in exponential form as base raised to x, that is base raised to exponent, that is equal to the number. Here the number is 0. Okay. Now what is the value of x? So that 10 raised to x is equal to 0. That is equal to minus infinity. That means x is equal to minus infinity. That is 10 raised to minus infinity is equal to 1 by 10 raised to infinity. That is equal to 1 by 10 raised to infinity. And 10 raised to infinity is infinity. 1 by infinity, that is equal to 0. So we get the value of x, that is equal to minus infinity when the number is 0. And okay, here the base is greater than 1. So use this. Suppose a raised to infinity. What is the value of a raised to infinity? A raised to infinity is equal to infinity if a greater than 1 and is equal to 0 if 0 less than a less than 1, and this is equal to 1 if a is exactly equal to 1. A is equal to 1. This is an okay. Now suppose the base is less than 1, that is lies between 0 and 1. That means log of, let base be 1 by 2 and the number is 0 is equal to question. Now we can write this in exponential form as 1 by 2 raised to x, that is equal to 0. Here a is less than 1, that is in between 0 and 1. So what is the value of x? So as to make this 1 by 2 raised to x is equal to 0 is infinity. X is equal to infinity. Since 1 by 2 raised to infinity is equal to 1 by 2 raised to infinity, that is equal to 2 raised to infinity is infinity. So 1 divided by infinity, this is equal to 0. We should remember. So log 0 to the base a is equal to minus infinity if a greater than 1 and is equal to plus infinity if 0 less than a less than 1. This is also one of the important properties. Now let us prove it graphically. Okay. Suppose the value of base a greater than 1. Alright. Then we can draw the graph of log base a n, that is log n to the base a. Here base is greater than 1 and we know that log 1 to the base a is equal to 0. For any values of a, the logarithm of 1 with respect to any base a is equal to always 0. So I am going to draw the graph of log n to the base a provided a is greater than 1. This is n and y-axis marking as log n to the base a. And when n is equal to 1, this is the value of n is equal to 1, the value of log 1 to the base a is 0. This point is marked. If n is greater than 1, the graph will exponentially increasing. Okay. And for n is lying in between 0 and 1, the graph will goes on like this. So this is the graph of log n to the base a if a greater than 1. Now, as n tending towards 0, that means n is approaching towards 0, the graph is approaching towards minus infinity. That means log 0 to the base a is equal to minus infinity. So this is clearly from the graph. And tending towards 0, the graph is going to minus infinity. Okay, clear. Now, if base a is lying between 0 and 1, that is 0 less than a less than 1. Let us draw the graph. And again, for any value of base a, the log 1 is 0. Right. Now, the graph look like this. This is n, the number, the positive real number n. And again, this is log n to the base a 0, such that a is lying between 0 and 1. When n is equal to 1, the value of the graph is 0. Okay. When n is between 0 and 1, the graph is exponentially decreasing. It's an exponentially decreasing function. Okay. So this is a graph of log n to the base a. This is exponentially decrease. So as n is tending towards 0, the graph is going towards plus infinity. That means n is approaching to 0, the graph is going to plus infinity. So log 0 to the base n, base a is equal to plus infinity. Okay. Now look at this graph. Now I am writing the condition base 0 less than a less than 1. Then log n to the base a is equal to, in this region, in between 0 and 1, the value of n is 1, and 0, in between the value of n is 0 and 1. The graph is lying above the real axis. That means the graph is positive. This implies log n to the base a is positive if 0 less than n less than 1. That is, n is lying between 0 and 1. Is equal to 0 if n is equal to 1. Is equal to, then if n is greater than 1, the graph is lying below the x-axis. That means this portion along the negative y-axis. That means graph is negative. So the value of log n to the base a is negative. This is negative if n is greater than 1. Okay. If base a is greater than 1, what is the graph? Our graph look like this. This is the value of log n to the base a. A is greater than 1. N. This is the point n is equal to 1, 0. So in between the value of n, 0 and 1, the graph is lying below the x-axis. That is along the negative y-axis. That means the value of log n to the base a is negative. At n is equal to 1, 0, when n is greater than 1, the graph is lying above the x-axis. That is positive. So we can write log n to the base a is equal to a negative if 0 less than n less than 1 is equal to 0 if n is equal to 1 is equal to positive. The graph is positive if n is greater than 1. This is also an important property. We should remember these two properties also. Okay. Now, log 0 to the base 2 is equal to, since a is equal to 2, that is greater than 1. So the value is minus infinity. Okay. Log 0 to the base 1 by 2 is equal to, here the base a is lying between 0 and 1. That is a less than 1 or 0 less than a less than 1. So the value of this is equal to plus infinity. Okay. And log 1 to the base 1 is not defined, since base a should not be equal to 1. And or log of minus 2 to the base 2, this is also not defined, since n is less than 0. This is also not defined. Right. Now we want to prove these all properties. Now consider the fourth property. Fourth property is log n to the base a plus log m to the base a is equal to log the product of m and n, mn to the base a. Base is same, right? Now we want to prove this. Now consider the LHS. LHS is log n to the base a plus log m to the base a. Let log n to the base a is equal to x. We can write this in exponential form as n is equal to a raised to x. And similarly, let log m to the base a is equal to y. So in exponential form, am is equal to a raised to y. Okay. Now consider the product m into n is equal to, m is a raised to y. A raised to y into n is a raised to x. Okay. This is equal to a raised to y plus x. Now taking logarithm on both sides of this equation, that is log mn to the base a is equal to log a raised to y plus x to the base a. Now using the property, that is the sixth property, that is log n raised to alpha to the base a is equal to alpha times log n to the base a. That we will prove. This y plus x will jump to here. So this is equal to y plus x times log a to the base a, and value of this term is equal to 1. So this is equal to y plus x, that is x plus y. Log mn to the base a, this is our RHS is equal to x plus y. X is log n to the base a, log n to the base a plus y. Y is log m to the base a. This is equal to LHS. Hence proved. Consider the fifth property. Fifth property is similar to that of the fourth property. That means log n to the base a minus log m to the base a, that is equal to log n by m to the base a. So our LHS is this term, that is log n to the base a minus log m to the base a. This is our RHS. Now put log n to the base a is equal to x. So in exponential form, we can write n is equal to a raised to x, and let log m to the base a is equal to y, and in exponential form, we can write m is equal to a raised to y. Now, divide n by m. N divided by m is equal to a raised to x divided by a raised to y. That is a raised to x minus y. Now take the log on both sides of this equation. That means log n by n to the base a, this is our RHS, is equal to log a raised to x minus y to the base a. Now, this will jump here. So, this is equal to x minus y into log a to the base a. The value of this term is equal to 1. This is equal to x minus y is equal to, what is our x? X is log n to the base a minus y is log n to the base a. Log n to the base a. This is our LHS. Hence, proved. Now, our sixth property is log n raised to alpha to the base a is equal to alpha into log n to the base a. Now consider the LHS. We can write LHS as log n raised to alpha to the base a. This is equal to log a is the base, n raised to alpha means n multiply alpha times. That is n into n into n into up to n. This is alpha times. Okay, that is n into n into n into up to n. And number of n's are alpha. So, by using the first property, that is log n plus log m is equal to log mn. So, we can write this is equal to log n to the base a plus log n to the base a. This continues up to alpha times. So, this is the summation of this term, alpha times. That is equal to alpha into log n to the base a. This is our RHS, hence proved. Now, using these properties 4 and 5, what is log a into b by c to some base x. So, we can write this is equal to log a to the base x plus log b to the base x minus log c to the base x. Okay, now log x to 1 of x, 2 into 5 into 7 by 9. This is equal to log 2 to the base x plus log 5 to the base x plus log 7 to the base x minus log 9 to the base x, using the properties 4 and 5. Consider the seventh properties, that is a raised to log n to the base a is equal to n. Now, for proving this, consider the term log n to the base a. Let this is equal to x. Okay. Now, we can write this in exponential form as n is equal to a raised to x. This means a raised to x is log n to the base a. That is a raised to log n to the base a. Okay. So, hence proved. This is our RHS and this is our LHS. Okay, when base is equal to 10, then it is called common logarithm. This implies common logarithm. Okay, that is log n to the base 10. This is our common logarithm. Then next is natural logarithm or Neperian logarithm. That is base is equal to e. That is when base is equal to e is a 2.73. Then this implies natural logarithm or Neperian logarithm. Right. That is log of any number x to the base e, that is denoted by ln x. Okay. So ln x means base is always c, that is called natural logarithm. And when base is equal to 10, that is called common logarithm. Consider log 2x plus 1 to the base 1 by 2 minus log x plus 1 to the base 1 by 2. This is equal to 0. Let. Then find the value of x. That means by using this property 5, we can write this as log 2x plus 1 divided by x plus 1 to the base 1 by 2 is equal to 0. Then by using exponential form, we can write this as 2x plus 1 divided by x plus 1, that is equal to 1 by 2 raised to 0 is equal to 1. Or 2x plus 1 is equal to x plus 1, or x is equal to 0. Okay, now consider the question log x square to the base 4 minus log x to the base 4. This is equal to 0. Find x. Now using the fifth property, we can write this as log x square by x to the base 4, that is equal to 0. So in exponential representation, x square by x, that is equal to 4 raised to 0 is equal to 1, or x is equal to 1. This is the answer. Now consider the question log of 1 plus x to the base 2 plus log x plus 3 to the base 2 is equal to 3. Find the value of x. So using property 4, we can write this as log base 2 1 plus x into x plus 3, that is equal to 3. So convert this into exponential form. We can write 1 plus x into x plus 3, that is 3 plus x is equal to 2 raised to 3. 2 raised to 3 is equal to 8. Okay, this same become x square plus 3x plus 4x plus 3 is equal to 8, or x square plus 4x minus 5 is equal to, that is factorizing this quadratic equation, we get x plus 5 into x minus 1, that is equal to 0. That is x plus 1 into x plus 5 into x minus 1 is equal to 0. This implies either x is equal to minus 5 or x is equal to 1. Okay. Now, when x is equal to minus 5, this term becomes log 1 plus minus 5, that is equal to log of minus 4. This is a logarithm of a negative number that is not defined. So, x is equal to minus 5 is not possible. So, x is always is equal to 1. So, in this type of problem, we have to check whether expression satisfying by putting the value of x. Okay. Now, consider the question. Log of 4 minus x to the base 2 is equal to 4 minus log base 2 of minus 2 minus x. Now, find the value of x. So, we can write this as log of 4 minus x to the base 2. This term can be taken into LHS plus log of minus 2 minus x to the base 2, that is equal to 4. Now, using the property 4, we can write this as log 4 minus x into minus 2 minus x to the base 2, that is equal to 4. Now, writing this in exponential form, we can write 4 minus x into minus 2 minus x is equal to 2 raised to 4, that is equal to 16. Or 4 minus x into minus can be taken outside, 2 plus x, that is equal to 16. This minus goes here, so minus 16. This is equal to 8 plus 4x minus 2x plus 2x minus x square is equal to minus 16. Or x square minus 2s minus 24, that is equal to 0. Now, factorize this as x minus 6 into x plus 4 is equal to 0. Is equal to 0. Or x is equal to 6 or x is equal to minus 4. When x is equal to 6, this term becomes log of 4 minus 6. That is equal to log of minus 2, a negative number. So, this is not defined. So, x is equal to 6 is not possible. Now, let us check x is equal to minus 4. When x is equal to minus 4, this term becomes log 4 minus of minus 4 is equal to 4 minus log base 2 minus 2 minus minus 4. That means log 8 is equal to 4 minus log base 2 plus 4, that is equal to 2. This is equal to 4 minus log 2 to the base 2, that is 1, is equal to 3. Is equal to 3. This is correct since log base 2 8 is equal to log 8 can be write as 2q to the base 2. This 3 will jump here. So, this is equal to 3 into log 2 to the base 2. The value of this term is equal to 1. So, the only solution is x is equal to minus 4. So, that is the answer. The question, log base 10 ab plus root of ab square minus 4 times a plus b. Okay. Plus log base 10 ab minus square root of ab square minus 4 times a plus b. Okay. This divide by 2 and this also divide by 2. Argument is divide by 2 is equal to question. We can write this as log base 10 ab plus square root of ab square minus 4 times a plus b divided by 2 into ab minus square root of ab square minus 4 times a plus b divided by 2. So this is in the form x plus y into x minus y. That is x plus y into x minus y form. That is equal to x square minus y square. So this becomes log base 10 ab into ab. That is ab square minus this term into this term. That is ab square minus 4 times a plus b by 4. This ab square and ab square get cancelled. This minus of minus become plus. So this is equal to log base 10 4 times a plus b divided by 4. This 4 and 4 get cancelled. Is equal to log base 10 a plus b. This is the answer. 2 raised to log 9 to the base 2. This is equal to, by using the property 7, this is equal to 9. This 2 and 2 get cancelled. Answer is 9. Consider 1 by 2 raised to log 9 to the base 2 is equal to the question. Now we can write 1 by 2 as 2 raised to minus 1 whole raised to log 9 to the base 2. This is equal to 2 raised to minus log 9 to the base 2. Or this is minus, this we can write this minus as minus 1 into log 2. This minus 1 goes to here to the power of 9 by using the property. So by using this property 6, we can write this is equal to 2 log 9 raised to minus 1. Here base is 2. This 2 and 2 get cancelled using the property number 7. This is equal to 9 raised to minus 1 is equal to 1 by 9. This is the answer. We know that x raised to m whole raised to n, that is equal to x raised to m into n. Right. Consider the question 2 raised to 3 log 3 base is 2. This is equal to question. Using the 7th property, this 3 can be written as the power or exponent to this 3. So this is equal to 2 raised to log base 2 3 raised to 3. Then using the 7th property, 2 and 2 get cancelled. This is equal to 3 cube is equal to 27. Now 1 by 3 raised to log 7 to the base 3 is equal to, we can write 1 by 3 as 3 raised to minus 1 log 3 raised to 7. That is equal to 3 raised to minus 1 into log 7 to the base 3. Or using this property, this minus 1 can be written as the exponent or power of 7. This goes to here. So this is equal to 3 raised to log base 3 7 raised to minus 1. That is log that is equal to 3 raised to log base 3 of 1 by 7. And using this property, 3 and 3 get cancelled. This is equal to 1 by 7. Consider the question 3 raised to 2 log base 3 7. So using this property, 2 can be written as a power of 7. So this is equal to 3 raised to log base 3 7 square. That is, this 3 and 3 get cancelled using property 7. The answer is this 7 square, that is equal to 49. Instead of 3, let us write 1 by 3 raised to 2 log 7 to the base 3. So 1 by 3 can be written as 3 raised to minus 1 whole raised to 2 log 7 3. This 2 will goes to here. So we can write this is equal to 3 raised to minus 2 log base 3 7. Then using property 6, this minus 2 goes to the power of 7. This is equal to 3 raised to log base 3 7 raised to minus 2, or is equal to 3 raised to log base 3 1 by 7 square. And this 3 and 3 get cancelled. This is equal to 1 by 7 square, that is 1 by 49 is the answer. Oh. Consider the question 1 by 4 whole raised to minus log 3. The base is 2. Okay. We can write 4 as 1 by 2 square whole raised to minus 1 into log 3 to the base 2. This is equal to, this 1 by 2 square can be written as 2 raised to minus 2. 2 raised to minus 2, the whole raised to minus 1 into log 3 to the base 2. This minus 2 into minus 1 become plus 2. That is equal to 2 raised to 2 log 2 3 base 2. This 2 goes to here. So this is equal to 2 raised to log 2 3 square. 3 square is 9. This 2 and 2 get cancelled. So the answer is equal to 9. Now the question is 2 raised to log x square base 2 minus 3x minus 4 is equal to 0. Find the value of x. Find x. Okay. So using this property, this 2 and 2 get cancelled. So this becomes x square minus 3x minus 4 is equal to 0. This is a quadratic equation. We can solve this quadratic equation. So we can factorize this as x minus 4 into x plus 1 is equal to 0. So x is equal to 4 or x is equal to minus 1. Here it is x square. So both x is equal to 4 and x is equal to minus 1 is satisfied. If k raised to log 5 to the base 2 is equal to 60, the value is given. Then we want to find the value of k raised to log 5 to the base 2, this is whole square, is equal to question. Okay. Now, okay, we can write this as k raised to, this is log 2 5 whole square. So this term can be written as log 5 to the base 2 into log 5 to the base 2. So that is equal to log 5 to the base 2 the whole square. Now using this x raised to m whole raised to n, that can be written as x raised to m into n. So using this relation, we can write this as k raised to log 5 to the base 2. This whole raised to n, that is log 5 to the base 2. The value of this factor is equal to 16. So 16 raised to log 5 to the base 2. 16 can be written as 2 raised to 4. So this is equal to 2 raised to 4 log 5 to the base 2. Now this 4 is going as a power of 5. So that is equal to 2 raised to log 5 raised to 4 base 2. And using this relation, this 2 and 2 get cancelled. This is equal to 5 raised to 4. 5 raised to 4 means 625. If a raised to log 7 to the base 3 is given as 27 and b raised to log 11 to the base 7 is equal to 49, then find the value of a raised to log 7 to the base 3 whole square plus b raised to log 11 to the base 7 the whole square is equal to question. This is similar to the previous question, and we can make use of this relation x raised to m all raised to n, that is equal to x raised to m into n. So we can write this term as a raised to log 7 to the base 3 whole raised to log 7 to the base 3 plus b raised to log 11 to the base 7 whole raised to log 11 to the base 7 by making use of this property. So the value of this term is equal to 27. So 27 raised to log 7 to the base 3 plus value of this term is 49. 49 raised to log 11 to the base 7. Now we can write 27 as 3 cube. That is 3 raised to 3 log 7 to the base 3 plus 7. 49 can be written as 7 square. That is 7 raised to 2 into log 11 to the base 7. This 3 jump here. This 2 jumps here. So this can be written as 3 raised to log 7 cube base is 3 plus 7 raised to log 11 square base 7. And using this property, 3 and 3 get cancelled, 7 and get 7 cancelled. So this is equal to 7 cube plus 11 square. That is equal to 464. Okay. E raised to ln 8 is equal to, ln means natural logarithm. That is ln 8 is equal to log 8, here base is e. Okay. Now we can write this is equal to e raised to log e 8, base is e. E and e get cancelled. This is equal to 8. Now e raised to x ln a is equal to, this is one of the important property we are making use of in various problems. Now this x will jump here. So we can write this is equal to e raised to ln a raised to x. Okay, this is a very important identity. That is e raised to x ln a is equal to e raised to ln a raised to x. So this can be written as e raised to ln means log e a raised to x. So e and e get cancelled. This is equal to a raised to x. That means a raised to x can be written as e raised to x ln a. This is a very important identity. It means a raised to x is equal to e raised to x ln a. So what is 3 raised to x? We can write 3 raised to x is equal to e raised to x ln 3. Now 2 raised to a can be written as e raised to a ln 2. E raised to y can be written as e raised to y ln 5. X raised to ln y. Okay, we can write this as equal to e raised to ln x raised to ln y. Here base is e and e get cancelled. So this is equal to x raised to ln y. Now this will jump here. So we can write this is equal to e raised to ln y into ln x. Okay, that is x raised to ln y is equal to e raised to ln x into ln y. Okay, e raised to log e, that is ln. here e the power ln 5. Okay, in this question, this is e raised to ln of 5. This is base e. Okay, now this will jump here. So we can write this is equal to e raised to ln 5 into ln, that is log e to the base e. The value of this log e to the base e is equal to 1. So this is equal to e raised to ln 5. That means e raised to ln 5. E raised to ln 5 means ln means log base c. E raised to log e base e 5. Again this e and d get cancelled. So this should be equal to 5. 2 raised to log base 2 e the power log base e 5. The power of 5 is log base 5 7. And power of 7 is log base 7 3. And the power of 3 is log base 3 of 8x minus 3. This is equal to 13. Then find the value of x. Okay, so this 2 and 2 get cancelled, e and e get cancelled, 5 and 5 get cancelled, 7 and 7 cancelled, 3 and 3 cancelled. So finally this become 8x minus 3, that is equal to 13, or 8x is equal to 16. This implies x is equal to 2. Okay, consider the question x raised to ln y minus ln z. This into y raised to ln z minus ln x. This into z raised to ln x minus ln y. Then what is equal to question? We want to find the value of this thing, this term. That is ln. Okay. We can write this term as e raised to log base e. This base e and e get cancelled, so there is no effect. Into x raised to this, into this term, that is x raised to ln y minus ln z. E and e get cancelled, so this whole factor is equal to x raised to ln y minus ln z. Now this term can be written as this into e raised to log base c, that is ln e, into this term, that is y raised to ln z minus ln x. E and e get cancelled, so this whole term is equal to this y raised this term. This into e raised to ln z raised to ln x minus ln y. Now this term ln y minus ln z will jump to here. This term will jump to here. This is jump to here. So we can write this as e raised to ln y minus ln z into ln x. This into e raised to ln, this term ln z minus ln x into ln y. This into e raised to, this will jump here, ln x minus ln y into ln z. Okay, now this is here in the form e raised to a into e raised to b into e raised to c, that is e raised to a plus b plus c. So we can write this is equal to e raised to this term, that is ln y ln x minus ln z ln x plus this term, that is ln z into ln y minus ln x into ln y, that plus the product of this, that is ln x into ln z minus ln y into ln z. Now all this term get cancelled. Ln y into ln x. That is minus ln x into ln x. This will be cancelled. Minus of ln z ln x. That is cancelled with this term. This is ln x ln z. And again this and this is cancelled. So this is equal to e raised to 0. So that is equal to 1. So 1 is the answer. Log 4 base is 4 by 3. 1.3 bar. 1.3 bar means that is recurring. 1.3 bar. That is equal to 1.33333 is equal to 4 by 3. So we can write this is equal to log base 4 by 3. This is 4 by 3. So this will cancel. The answer is equal to 1. Now consider the question. Log base 5 square root of 5 square root of 5 square root of 5 square root of 5. This will go up to infinity. So what is the value? Is the question. We can write this as log base 5 first square root of 5, that is 5 raised to 1 by 2 into this is square root of 5, that is 5 raised to 1 by 4. This is square root of 3 times square root, that is 5 raised to 1 by 8 into 5 raised to 1 by 16. This goes on. So we can write this as log base 5 raised to 1 by 2 plus 1 by 4 plus 1 by 8 plus 1 by 16. That goes on. This is an infinite GP. That is 1 by 2 plus 1 by 4 plus 1 by 8 plus 1 by 16. This is an infinite GP. Then sum to infinite term, that is equal to a by 1 minus r. Here first term is 1 by 2 and r is 1 by 2. That is 1 by 2 divided by 1 minus 1 by 2. That is equal to 1 by 2 by 1 by 2 is equal to 1. So this is equal to log base 5 of 1. That is equal to 0. Log 8 to the base 0.125. Okay. We can write this is equal to log 1 by 8. 0.125 means 1 by 8. 8. That is equal to log 8 raised to minus 1 minus of log 8 to the base 8. This is equal to, this term is equal to 1. So this is equal to minus 1. Log some base a, b square. We can write this as, this 2 will jump here, is equal to 2 times log base a b. Okay. And suppose log b to the base a square. This can be written as 1 by, this 2 will come in the denominator of 1. 1 by 2 into log b to the base a. This is an important identity. Now, 7 raised to log x base 7 plus 2x plus 9 is equal to 0. Find the value of x. This 7 and 7 get cancelled. This from x plus 2x plus 9 is equal to 0. Or 3x plus 9 is equal to 0. Or x is equal to minus 9 by 3. That is equal to minus 3. Log, here base is x. 2x square minus 9 is given as 2. Find the value of x. So we can convert this into exponential form. So we can write this as 2x square minus 9, that is equal to x square. Or x square is equal to 9. X is equal to plus or minus 3. We have two values. For x is equal to 3 and x is equal to minus 3. Here base is x. Base is always greater than 0. So this value is not possible. So the answer is x is equal to 3. Now, log x square minus 1 to the base 2 is equal to 3. Find the value of x. So, represent this in exponential form. We can write x square minus 1 is equal to 2 raised to 3. Or x square minus 1 is equal to 8. Or x square is equal to 9. X is equal to plus or minus 3. So, here it is x square. So, both values of x will satisfy. So, when x is equal to minus 3, this becomes log base 2 minus 3 square minus 1. That is log base 2 minus 3 square is equal to 9 minus 1. That is log 2 8. So, 8 can be written as 2q to the base 2. This 3 will jump here. This is equal to 3 into log base 2, 2. This value is equal to 1. So, this is equal to 3. When x is equal to plus 3 also, we will get the same answer 3. So, both values are satisfied. Find the value of log 40 base 2 minus log 10 base 2. Okay, this is log a minus log b form. We can write this as log 40 by 10 to the base 2. That is log 4 to the base 2. 4 can be written as 2 square. So, this is equal to log 2 square to the base 2. This 2 will jump here. So, this is equal to 2 times log 2 to the base 2. This term is equal to 1. So, the answer is 2. Log base 11 raised to log 11 1331. This is equal to question. Okay. Now 1331 is equal to 11 cube. So we can write this as log base 11 raised to log, here base 11 cube. This 3 will jump here. So this becomes log base 11 raised to log 10. Here 3. The value of log 11 to the base 11 is 1. So this can be written as log base 11 raised to 3 into 1. That is 11 raised to 3. This is equal to 3. So this is equal to log base 11 raised to 3. This 3 jump here. So this is equal to 3 into log 11 to the base 11. The value of this is equal to 1. So answer is equal to 3. Now 10 raised to log base is 100 16. This is equal to question. We can write this as 10 raised to log 100 can be written as 10 square. 16 can be written as 4 square. Now, using the identity, log a b square is equal to 2 times log b to the base a, and log a square, base is a square b, that is equal to 1 by 2. This 2 will come in the denominator of log b to the base a. So, we are making use of this identity. So, we can write this is equal to 10 raised to log, here 10 square. So, this here 4 log 10 square. So, that will come under denominator 1 by 2, here 10. Then 4 square, this 2 will come here in the numerator, 2 into 4. That is equal to 10 raised to 2 by 2, that is 1, log 10 4. This 10 and 10 will cancel. This is equal to 4. Okay, in the next class we will discuss the questions, the previous questions of JEE main from logarithmic functions. Okay, thank you. Bye.